start from where we left in the last class. It's lecture number 2. Here we will talk about operators. So, before operators, uh, like operators always work on a data, and every piece of data has a data type. So, let's discuss about data type. As you already know, we have discussed in previous classes, like if we are defining a variable age, its data type is integer. We have to do it in C because it is a statically typed language, which we don't do in Python. So in C, if you remember, we have some categories and their examples. So basic, we had character, integer, float values, and double. Double used for store large float values. It all depends on the compiler size. Like it can be of 4 bits, sorry, 8 bits or 16 bits. And then float can be of more, like depends upon the compiler. Uh, then we have some derived data types. For example, array, pointer, structure, union, and enumeration, you know, and void. But in Python, we don't have like all of these type of data types. Like we have some, but we doesn't have to explicitly tell the Python interpreter that this is integer, float, or whatever it is. For example, if you write a variable and assign some value, so when you in Python you can print the class. So when you use the statement print type age, so you will see it will return class str string. Another example is if you take x equals to 10, and if you print type x, then it will say class integer. Uh, Another example we can take is if you like print type of any boolean value true, so you will see it will state it as a class bool. So what does that means? It means the Python libraries also have function classes which contain this data types boolean, integer, string, and they dynamically know the type when we assign some constant value to a variable. So if we talk about Python, the category we have and the data types we have are numeric, the same. We have here integer, float, and complex values. We can also store for boolean. The class type is bool. Then for a string, we have str. Here we have for sequence, we have list, tuple range. Like we will use this for array creation and all, and this also have some specific qualities. We will see them in later videos. We have set for mapping. We have dictionary. We will see them all later. And then we have binary data types and special data types. So let's talk about our today's topic, operators. So what is operator is? Operator is a symbol or a keyword that performs an operation on one or more operands. You have operand, then you perform some operation. So yeah, you can have multiple operands and can perform multiple operations. For simplest example, a plus b, you will assign a some value 10, b some value 5, then print a plus b. So here we will understand the types of operators. So first one is arithmetic, second assignment, third comparison or relational, fourth we have logical operators, we have bitwise operators, membership and identity operators. We will discuss all of them one by one. So what are arithmetic operators? These are just mathematical operations you have seen, like addition, subtraction, multiplication, division. Addition, subtraction, multiplication. But we have multiple divisions like this division with single slash. If you perform this, for example 10 divided by 5, so it will give you a floating point value. There is double slash which we call floor division. So if you perform floor division, for example 10 divided by, it calculates the floor value. So it's come out to be 3. Then we have modulus, or what we say remainder operator. It calculates the remainder. For example this, it's not like floor division, it will output the remainder of the operation. Then we have exponentiation operator, just exponents the value. So you can try these operators. Next we have assignment operators. Oh, for like this the variable, we assign it an integer value. So assign operator this is. Then we have plus equal. What does this mean? There is pre increment. So first increment, then assign the value. For example, if I say x plus equals to 5, it means first increment the value of x by 5 and then assign this value to the variable x. This is pre. Then next we have the similar for subtraction. If I say this, so first decrement the value x by 5, then assign it to x. This is the meaning. Then we have same for multiplication operator, for division operator, for floor division operator, for modulus operator, and for exponentiation operator also. Then comes the comparison operator. So this used to compare two values. For example, this is the assignment operator. But what if we have to compare two values if these are equal or not? Then we use the equals to operator for comparison. Then we have this is equal to. Then we have not equal to operator. Then we have greater than, less than, greater than equal to, less than equal to. We will see the program for these uh, in next few lectures. Then we have logical operators. Logical operators like and, or, not. This is the logical and operator, or and not operators. So how does they work? Let's take an example. Suppose if I have a equals to 10 equals to 20, if I say print a less than b and b greater than 15. So what does that mean? A is less than b. Let's create a and table. It would be easy. X, y, and. So you know the output of and. If it's true in both cases, then it's true. Else everywhere it's false. False, false, false. False, true, false. True, false, false. True, true, false. This is the only case. Sorry, true. This is the only case it's being true. So yeah, A is less than B. A is less than B. If we talk about this, 10 is less than 20. So it's a true condition, and B is greater than 15. What is B? 20 is greater than 15. It's a true condition, true and true. So yeah, this statement outputs true. If you want to take another example, uh, let's print A greater than B or B greater than 15. So let's create OR table X, Y, OR. For OR, it's every time true, but when both inputs are false, this is false. Else every time it is true, true, true. So yeah, A greater than B. 10 is greater than 20. No, false. Or B greater than 50. B is what? 20 greater than 50. This is true. False or true. This is always true. This is the output it will say. If you want to take example of not operator, so yeah, it will output true, and we have negation, so it will print false as final. Then next comes the bitwise operator. So bitwise operators operate on the binary representation of integers. So like it first create the binary representation of integer, then performs the bitwise operation. For example, bitwise AND. Uh, we have bitwise XOR. We have bitwise NOT. We have left shift, and we have right shift. So we will see example of these operators also. For example, if you take example like I will take I equals to 23, j equals to 14. So yeah, if we convert this into binary, it would be 0 1 1 1 1, and if I take binary of this, it would be 0 1 1 1 0. Yeah, so if we perform the bitwise AND operation, it is 1 1 1. Sorry, we are doing bitwise AND operation. So yeah, 1 0 it is 0 1 1, it will output 1 1 1, it will output 1 0 1, it will output 0, it will output 0. For the case being true along x and y, it will only output true when both cases are true. So it corresponds to 6. Yeah. So when you print this, it will output 6. If I have to take the no, we have so if you want to take XOR operation, you can also take. So what does XOR do is it's when the outputs are different. For this case, it will output 1. Sorry, when the inputs are different, it will output 1. But when the inputs are same, it will output 0. So yeah, these are different. 1 1. These are same, so 0. This corresponds to a decimal value of sorry, 25. There come the shift operators. Shift operators does nothing, but it shifts the value. How it shifts the value? Like uh, if we take an example, a equals to 17, b equals to 9. So if I calculate the left shift it by 2. So for a z learning, we have a formula. If this is your variable, which we have a here, and we left shift by some count, we have 2 as a count value here. So for left shift, we does variable star 2 power count. So what does it output? It outputs 17 into 2 power 2. So it's 68. If it's a case of right shift, you can do variable float division to power count. So yeah, for example, if this time you take variable 2 uh, and count value, let's say 3, well, right shifted by 3 values, so it would be like 9 for division 2 by 3, 1. So yeah, but in actual, how you visualize this, in actual, what does the shift mean? The shift is doing nothing, it just shifts the binary value which we are having by the number of count values we are getting. For example, if you have some uh, binary value, let's take a 8-bit binary value, 1 2 3 4 5 6 7 8 0 0 0 0 1 0 0 0. So what does left shift mean? You will have this array. So each bit is shifted to left. Another bit 0 is introduced here. It will become like this, but this bit will shift here 0. This will shift here 0. This will shift here 0. This will shift here 1. This will shift here 0. This will shift here 0. This will shift here 0. This will shift out the box because it's a left shift. The left value became out of box. If I say 1 count, if I say 2 count, it will shift by 2 values. So these two will be out of box, and it will now start shifting by 2 values. So yeah, that's it for this video.